So this little video is just a bonus video. It's a summary or a review of all the different types of factoring. The different types of factoring that we looked at were greatest common factor, what I call simple trinomials, when you have an ax squared plus bx plus c where the a is equal to 1. Hard trinomials, what I mean by hard trinomials is when the a value is bigger than 1, and we use the method of decomposition to solve those, or to factor those. And then the last one was special factors, so we looked at difference of squares, that happens when you multiply conjugate binomials, and perfect trinomial squares, that's what happens when you square a binomial. So what I find when I'm working with students in the classroom is that most people do okay with each type of factoring as we learn it day by day, but then when we get them all mixed up on a page and they have to decide what type of factoring there is, what type of factoring to use, then that can cause some troubles. So what I have here is, I'm just going to give you a little suggestion on the order to look for types of factoring. So what I suggest is to look at the number of terms. And it doesn't matter if there's 2 terms or 3 terms or 4 terms. The first type of factoring you should always look for is the greatest common factor. That's the first type of factoring that you should always check out. And I'll do an example of the greatest common factor. So say if I had 15x squared minus 20xy. That's only 2 terms, but I'm going to look for a greatest common factor, and I can see there's a common factor of 5 and a common factor of x in both of those terms. So I'm going to factor out the 5x. Factoring means divide. 15 divided by 5 is 3. X squared divided by x. Negative 20 divided by 5 gives me a negative 4. X divided by x is 1, and y is remaining. So that was 2 terms, but greatest common factor should always be the first type of factoring you look for. Sometimes you can do greatest common factoring and then another type of factoring. Okay, the next one. If it's not greatest common factor and it's 2 terms, it would have to be difference of squares. So I'll give an example of a difference of squares. If I had 49x squared minus 36. It's only 2 terms. There's no greatest common factor. Difference of squares. When you recognize that it's difference of squares, you immediately open up 2 sets of brackets. You take the square root of the first term, the square root of the second term. One gets a plus sign, one gets a minus. If it's 3 terms and it's not greatest common factor, there's actually 3 different ones that it could be. So it's 3 terms. You're going to pick out the simple trinomial right away, because a simple trinomial is in this form that it doesn't have any number in front of the x squared. With a simple trinomial, you can open up your brackets right away. And sometimes I kind of do this off to my side. I think, okay, what 2 numbers multiply together to give me 14 and add up to give me 9? And the 2 numbers that multiply together to give me 14 and add up to give me 9 are 2 and 7. So the x plus 2 and x plus 7. That is a simple trinomial. An example of a hard trinomial is if I have a number out front, so 12x squared minus 11x minus 5. With a hard trinomial, I started off the same way as the simple trinomial. I say what 2 numbers multiply, what 2 numbers add up. But this time I have to take the 12 and the 5 into consideration. So 12 times negative 5 is negative 60, and then adds up to give you negative 11. Now I could go through all the factors of 60, so 60 and 1, 2 and 30, but it's going to be a 15, a negative 15, and a positive 4. Now with hard trinomials, we have to do a couple extra steps. We have to break down that middle term using those two numbers I found, so negative 15x plus 4x. Now I do what's called factor by grouping. So I look at the first two and I look at the second two. The greatest common factor there is a 3 and an x, and it leaves me with 4x, take away 5. And I alluded to this on my last video. What I want in my next bracket is 4x minus 5, and that's exactly what I have. There is no greatest common factor to 4x minus 5. So what I'm going to do is I'm going to factor out a 1. And it won't change anything. Now I have a 4x minus 5 common to both of them. So I have 4x minus 5 and then 3x plus 1. So we have simple trinomials. You can do them in one step. That's why I call it a simple trinomial. Some teachers will just say it's a trinomial with the a value is equal to 1. Hard trinomial is where the a value is bigger than 1. And then the perfect trinomial square. This is the best catch of all. If you happen to recognize a perfect trinomial square, it will save you time and energy. So say for example, if I had 100x squared minus 180x plus 81. If I first looked at that, I might say it's a hard trinomial, and I could still do it the way that I did up above. But if you recognize that that first number is a perfect square, which is 10, and the last number is a perfect square, which is 9, and 10 times 9 is 90, doubled is 180, then that is all the makings of a perfect trinomial square, and we can just immediately jump to the final answer. The square root of 100 is 10, the square root of 81 was 9, and it was subtract because it was take away 180x. So that's just a little summary of all the different types of factoring, and when it's all mixed together on the page, we'll always look for greatest common factor first. If it's 2 terms, look for difference of squares. If it's 3 terms, try to decide if it's a simple trinomial, a hard trinomial, or it might even be a perfect trinomial square. Good luck. Thanks for watching. Have a great day.